This carton has the word natural printed on it in green letters. It also contains 26 grams of fructose per cup. And fructose, the specific kind that comes from industrially processed fruit drinks, is one of the most potent triggers of arterial calcification that researchers have identified in the last decade. I'm going to show you the exact mechanism, step by step, because this isn't a theory. This is the same process I've seen described in post-surgical arterial tissue analysis. The pathway from that morning drink to calcified plaque is not a long one, and most people pouring that glass right now have no idea it's happening. Calcifying, that's the word, and I'm going to show you exactly what it means inside your body, in a sequence that starts within 2 hours of that first morning sip. If you drink juice in the morning or give it to someone you love, stay with me for the next 20 minutes. My name is James Reyes. I'm not a doctor. I'm a researcher, an independent one. I read the primary literature, the journals, the trials, the mechanistic studies, and I do this work because I've learned the hard way that being informed is not optional. I want to be clear up front. Nothing I say here is medical advice. What it is the research your doctor may not have had time to read this week, because the studies I'm going to walk you through today are real, peer-reviewed, and they change the conversation about what healthy actually means before 7 a.m. Here's what I want you to hold on to through this entire video. There is a mechanism, a specific, documented biological chain of events that happens inside your arteries within 2 hours of drinking certain beverages. And that mechanism doesn't care whether the label says natural, organic, or no added sugar. It doesn't care about the vitamins listed on the side panel. It responds to one thing only, the fructose load and how fast it arrives. I'll show you what stops it, but first I need you to understand what starts it. Drop a comment right now with just your age, nothing else. I want to see who's watching, because what I'm about to show you depends on exactly where you are in this. For 40 years, the public health message around juice was essentially, it's not soda, so it's fine. Fruit has vitamins, it's natural, it hydrates. The guidelines said reduce processed food, and juice was never fully on that list. In fact, for a generation of people, orange juice was the responsible choice. The thing you gave your kids instead of soda. The thing you switched to when your doctor told you to eat more fruit. But here's what happened in the research during that same 40 years, quietly, in cardiovascular journals that don't make the news. Researchers started separating types of sugar, not just sugar is bad. They started asking, what does fructose specifically do once it gets past the gut, into the liver, and from there into the bloodstream? And let me say this carefully because I want to be precise. They found something that nobody in the public health conversation was ready to talk about. Fructose from industrially processed beverages, juice included, activates a pathway in the liver that is fundamentally different from what glucose does. The liver treats this fructose as an overflow signal. It converts it into triglycerides, and those triglycerides flood the bloodstream. That alone would be bad enough, but here's where it gets worse. Those elevated triglycerides don't just raise your overall lipid count. They do something structural. They remodel the LDL particles circulating in your blood, making them smaller, denser, and more dangerous than standard LDL. And that dense LDL, this is not speculation, this is mechanistic, penetrates the arterial wall more easily than regular LDL. It gets inside the endothelium, and once it's in there, it oxidizes. That gap between what the research on fructose and vascular biology now shows and what's printed on that natural label is costing people their arterial health silently over years. When was the last time anyone explained to you what your morning routine was doing to your arterial wall? Not your weight, not your sugar count, but your actual arterial wall. Has your doctor ever walked you through that mechanism, or did the appointment end before you got past the lab numbers? That's the question I kept asking, and the answer, when I went into the literature, is what I'm bringing to you today.
3 weeks ago, I was going back through a study I'd first read 2 years ago, and I pulled it again because a comment on a previous video made me want to confirm something. The study is the Brisighella Heart Study, published in Nutrients 2019, conducted in Italy over multiple cohorts. Sample size, 1,694 people. The researchers measured something called CFPWV, carotid femoral pulse wave velocity. If you haven't heard that term before, here's the translation. It's how fast a pressure wave travels through your arterial wall. The faster it travels, the stiffer the arteries. And arterial stiffness is a direct, independently validated predictor of cardiovascular events, cognitive decline, and all-cause mortality in people over 60. Write this down. In the Brisighella study, fructose from industrially processed beverages was a statistically significant independent predictor of elevated pulse wave velocity, even after controlling for total caloric intake, body weight, and other metabolic factors. The regression coefficient was B equals 0.310. The 95% confidence interval was 0.099 to 5.222. That means the association was not noise, it was signal. Now, I need you to understand what independent predictor means in this context. It means even after the researchers accounted for everything else that could explain higher arterial stiffness, age, BMI, blood pressure, smoking history, fructose from beverages still showed up as its own risk factor, separate, additive, real. What this means in practical terms is that you could have a doctor reviewing your labs, seeing everything within normal range, and still have fructose from beverages silently driving a process that conventional panels are not designed to detect. A woman I want to tell you about, she was 61, retired teacher, lived in a mid-sized city in the Midwest. She had been drinking 2 glasses of 100% orange juice every morning since her cardiologist told her to reduce red meat and eat more fruit. Her cholesterol looked acceptable at her annual checkup. Her blood pressure was managed. She felt like she was doing everything right. Every morning, glass in hand, standing at the kitchen counter before the rest of the house woke up, following the advice she'd been given. Nobody had ever tested her arterial stiffness. Nobody had ever explained that the juice she was pouring every morning, faithfully, religiously, was triggering the exact lipid cascade the literature now associates with progressive arterial calcification. She only found out when she asked a different question at a different appointment. When she walked in with the research in hand and said, "I want to understand what's happening to my arterial wall, not just my cholesterol number." That question is at the end of this video. Stay with me. If this matches something you've been doing and had no reason to question, type yes in the comments. I think the number is going to be significant. Here's the full chain, because you deserve to understand every link. Step 1. You drink the industrially processed fructose. Step 2. The liver receives it, activates de novo lipogenesis, fat synthesis. Triglycerides rise. Step 3. Elevated triglycerides cause structural remodeling of LDL. The particles become small, dense. Small, dense LDL, or SDL, penetrates the arterial endothelium more easily than standard LDL. Step 4. Once inside the arterial wall, that small, dense LDL oxidizes. Oxidized LDL triggers an immune response. Macrophages arrive. They ingest the oxidized LDL. They become engorged. Step 5. Those engorged macrophages, now called foam cells, die inside the arterial wall. Their lipid contents remain. This is the beginning of an atherosclerotic plaque. Step 6. Over time, calcium deposits accumulate around the plaque site. The wall hardens, the artery loses elasticity. And the stiffness that the Brisighella researchers measured with their pulse wave velocity instrument, that stiffness is the downstream result of what began with step 1. This is not a theory. This is the documented sequence, and it starts, for some people, with a drink that says natural on the label. Before I get to the part that changes everything, does this sequence match something you've been feeling but couldn't explain, or were you told your numbers were fine and left it at that? The second study I want to tell you about makes this harder to ignore.
The CARDIA study, Coronary Artery Risk Development in Young Adults, has been running since 1985. It's one of the longest cardiovascular cohort studies in the United States. In 2024, researchers published findings specifically on the relationship between sugar-sweetened beverage consumption, including juice, and coronary artery calcification progression. Write this down. Over a 9.2-year follow-up period, cumulative consumption of sugar-sweetened beverages was significantly associated with the progression of coronary artery calcium scores, a direct imaging measure of arterial plaque calcification, independent of dietary pattern, physical activity, and traditional cardiometabolic risk factors. 9.2 years, not months, years of progressive calcification associated with the beverage pattern people maintained while believing they were being careful. Here's the contra-intuito, the part that most conversations about this topic skip entirely, and the part that, in my view, is the most important finding in this space right now. The risk difference between sugar-sweetened soda and 100% juice was smaller than expected. I want to make sure I say this exactly right, because nuance matters here, because it always matters. The researchers differentiate. Naturally squeezed orange juice, consumed fresh, whole, that's a different metabolic conversation. The fructose delivery rate is different. The fiber context is different. But industrialized juice, pasteurized, concentrated, reconstituted, or extended shelf life, delivers fructose in a pattern that is metabolically closer to soda than to eating an orange. And nobody is telling that to the person who pours it every morning because they read that fruit is heart healthy. That gap between the marketing of natural and the mechanism of fructose delivery to a liver that doesn't distinguish labels, that, in my view, is the most overlooked conversation in preventive cardiology right now. Nobody told you that. I want to know, were you ever specifically told the difference between fresh squeezed and industrialized juice, or were you just told eat more fruit and assumed juice counted? There's another person I want to tell you about. He was 67, retired engineer. Every morning he made what he called his heart drink, a blend of orange juice and pomegranate juice he'd read about online. He'd been doing it for 6 years. He had his cholesterol checked annually, and his doctor called it well managed. He was proud of his morning routine. He talked about it with his wife the way people talk about habits they're certain are good for them. When he finally had a calcium score done, not because his doctor ordered it, but because he'd read something that made him ask, the result was higher than anyone expected. Not catastrophic, but not the result of someone who had been doing everything right. His doctor's response was, "Your cholesterol has been fine. This is sometimes just genetics." His response to that was to come back with questions, better questions, about his LDL particle size, about his arterial stiffness, about what he was drinking every morning. Nobody told him that the fructose in his heart drink was contributing to the process he'd spent 6 years trying to prevent. The myth this video is built to correct is this, that fruit juice is heart protective because it contains vitamins and is derived from natural sources. The mechanism doesn't care about the vitamins. The mechanism responds to the fructose load, the delivery speed, and the absence of the fiber matrix that slows absorption in whole fruit. A glass of commercial orange juice and a glass of soda produce different micronutrient profiles. They produce remarkably similar hepatic fructose responses. Here's the analogy I use when I'm explaining this to someone for the first time. Think of your liver as a receiving dock with a limited processing capacity. When you eat a whole orange, the fiber is the gatekeeper. It slows how quickly fructose enters that dock. The dock processes it without flooding, no overflow. Everything moves through in an orderly way and the system handles it. When you drink processed juice, there's no gatekeeper. The fructose arrives all at once. The dock floods. The workers, your liver enzymes, can't process it fast enough in the glucose pathway, so the system switches to fat production. Triglycerides are the result, and the cascade begins from there. Same source fruit, completely different physiological event. Read that again.
Here's what I don't want you to do with this information. I don't want you to feel like everything you thought you knew was a lie. The research on whole fruit is clear. It's associated with cardiovascular protection. The research on vegetables and whole food plant intake is clear. None of that changes. What changes is one specific habit, and this is where I need you to go from information to action. 3 concrete replacements with specific numbers and mechanisms, not generalities. 1. Water with lemon and a pinch of mineral salt. If you're over 60 and you're drinking juice in the morning to hydrate and get vitamins, this replacement gives you hydration, trace minerals, and vitamin C without the fructose load. The fructose delivery stops. The cascade doesn't start. That's the mechanism working in your favor now. And if you miss the taste, a small squeeze of orange into still water gives you the aroma and a fraction of the fructose, with most of the pulp intact. That's a completely different event for your liver. 2. Green tea, brewed, not sweetened. A 2020 meta-analysis in the European Journal of Preventative Cardiology found that regular green tea consumption was associated with reduced arterial stiffness scores, the same metric the Brisighella study used. You're not just removing a trigger, you're potentially adding a protective signal. 2 cups in the morning, no milk, no sweetener. The catechins do the work without the sugar. 3. If you want something that genuinely resembles juice, make a smoothie with half an avocado, a handful of spinach, a tablespoon of olive oil, and berries. You keep the fiber matrix, you keep the micronutrients, you avoid the fructose flood. The dock stays organized. The difference in how your liver handles a blended whole food smoothie versus processed juice is not subtle, it's structural. None of these require a prescription. None require a specialist appointment. None require you to give up flavor or nutrition. What they require is knowing that the mechanism exists, which is why you just spent 20 minutes understanding it. You are not a passive recipient of medical decisions. You are an informed participant in your own health, and what you put in a glass before 8 a.m. is a medical decision. If you're walking away from this video differently than you walked in, drop "informed" in the comments. That word tells me this reached you, and it tells the algorithm this conversation matters. Let me give you the 3 things to carry out of this video. 1. Industrially processed fruit juice delivers fructose in a way that triggers a specific hepatic cascade. Arterial pressure rises, LDL becomes small and dense, arterial penetration increases, oxidation begins, foam cells form. 2. The Brisighella Heart Study and the CARDIA 2024 findings both associate this pattern with measurable arterial stiffness and calcification progression over time, independently of other cardiovascular risk factors. 3. The replacement is not complicated. It's water, green tea, or a whole food fiber intact smoothie. The mechanism stops when the fructose flood stops. There's someone in your life who pours juice every morning because they're being careful about their health. You know who it is. Share this with them. That's the whole point of doing this work. And if this is the kind of research you want to keep seeing, the subscribe button is right there. I don't post every day. When I post, it matters. One thing I haven't told you yet, there's a specific blood test that can tell you whether the process we just described has already started in your arteries, and most routine panels don't include it. It's not a calcium score. It's a lipid subfraction test that identifies small, dense LDL particles directly. In a future video, I'll walk you through exactly how to ask for it, what the numbers mean, and what to do if your result is outside the range. Make sure the bell is on. That video matters. Of the 3 replacements I just gave you, lemon water, green tea, or the whole food smoothie, which one are you starting this week? Tell me in the comments. I'll be reading. Take these 3 steps to your next appointment, not instead of your doctor, alongside them. Show them what you learned here. Ask about your LDL particle size. Ask about your arterial stiffness score. Ask whether a calcium score makes sense for you now. I'm a researcher, not a clinician, but I read the studies, and what you do with this information is a conversation to have with your doctor, one you now walk into prepared. That's the difference.